It's a proactive fertility hormone testing company. But I'm not going to talk too much about that. What I really want to talk about is really get into some reproductive biology, women's health, and how hormones are an integral part of that. So bear with me as I play around with these slides and make sure I get everything working. Okay, so there's going to be a few things we're going to talk about today. First thing we're going to talk about is AMH, or anti-Müllerian hormone, and fertility. So I'm going to focus very specifically on the biology of what this hormone is doing in our bodies, if you have ovaries, and its role in fertility. Then we're going to talk a little bit about ovarian reserve testing, why it's useful, and what are some of the criticisms and critiques about actually using this in a proactive way. Hopefully we'll have some time at the end to actually debate, like, is proactive fertility testing useful or not useful? And I want us to debate, talk about it. You don't just need to hear me give my perspective. I want to hear from everyone. And then one of the things that I'm really interested in and I think is really fascinating is I spent a lot of my career in academia, in a lab, doing research, and then I left and went to industry. And so I think it's fascinating. If you're not in industry, if you're not in this space, you may not have any idea of what's going on in industry. And so I think it's a really fun opportunity to talk about what's going on, what companies are out there, and the different spaces they're playing in. So if we don't have enough time to get to that, we won't, but it's there at the end if we get there. I guess the only other thing I would say before I get started, I really want to re-emphasize this, that I really want to hear your questions. So I can stand up here and I can talk for an hour, no problem. But it's much more interesting if you guys are asking me the things that you care about, the things that you have questions about, and if we derail completely, so be it. But with that, I'll go ahead and get started, and we're going to start with AMH and fertility. So just as a quick refresher, I'm sure, hopefully, all of you are very familiar with this picture. So it's a little bit of a stylized, illustrative example of the female reproductive tract. And I'm just going to go over very quickly, just to make sure we're all on the same page, some of the key points. So here in red, we have ovaries, so typically 2 ovaries, 1 on each side. Those ovaries, oh goodness, you were right. Yep. I'm gonna, it's okay. Whew, I'm gonna be doing this a lot, I think. And then it's a little bit difficult to see, almost in a tan or flesh color here. Fallopian tubes connect the ovaries to the uterus. Every month, typically when things are happening normally, the ovary will release 1 egg. That egg will travel into the fallopian tube, and in the fallopian tube for about 12 to 48 hours on the late side, but typically 24 hours, that is when an egg can get fertilized by sperm in the fallopian tubes. So all of this, totally, you guys you know this. Great. That egg will go to the uterus, right? And if it is fertilized, it'll plant into the endometrium, or the lining of the uterus. And then if it doesn't implant or it isn't fertilized, all of the lining of the endometrium, including that egg, will be flushed out through the vagina as part of our monthly menstrual cycle. Okay, sounds like we're all on the same page. You guys are experts on this. Something that I think is really important to think about is how many eggs we have in our ovaries, for those of us who have ovaries, over our lifespan. And so this is showing different stages in development. From the first 3 here are in utero, and then after birth. That the number of eggs that a female fetus, and then through birth, puberty, and menopause, starts at around 1,000 at 5 weeks gestation, rapidly skyrockets to over 6 million, and then just as rapidly starts to decline. So at birth, there's only about 100 eggs in the ovaries. By puberty, that number has dropped to about 400,000. And between puberty and menopause, which are the reproductive years, the 400 at puberty slowly and over time are lost till we reach menopause, which is when our egg count has gone to 0. So I'm going to stop. Any questions? Any thoughts? Is this surprising? Do you already know this? Yeah.
So if you go into menopause at the age 39, 40 years old, that means all your eggs are just growing. Why are they growing so fast?
Yeah, Great question. We're going to get into it a little bit later on, but that's exactly right. So if you reach menopause at age 30 or age 40 or age 50 or age 60, that is because the number of eggs that you have in your ovaries has gone down to 0. And so what this table doesn't show is that there is some variation among women. And so we talk about averages, right? At puberty, there's an average of 400,000. In reality, our best estimates are that it varies between 300,000 and 500,000. So you can imagine if you were on the low side at puberty, you're going to potentially reach menopause sooner as those eggs run out sooner. And if you're on the high side, you will potentially reach menopause later. And I've got some great graphs. I wish I could show everything all at once. I've got some great graphs that we'll talk about that. But keep bringing up that question if I haven't answered it as we go through. But you're absolutely right. If it's 30, if it's 40, it's because the eggs have gone to 0. Any other questions? Yeah?
Wait, so what happens with the eggs between birth and puberty?
So it's a good question, and I think to a large extent it is very difficult to study the ovaries of young women to puberty. There's just not a lot of access to that organ and those cell types. But our best understanding of what is going on is that a lot of this is, and this gets to your question as well, cell death, which sounds terrible, or apoptosis or atresia, that cells are being degraded potentially because they're low quality, potentially because of damage that they're exposed to, and because this is what we know in biology, there's some biological process that results in the loss of eggs over time, and that's also what we see after puberty as well. Okay. So I want to switch gears a little bit and talk about hormones, because as I probably don't have to tell you guys probably already know that the reproductive system is tightly controlled by hormones. Hormones are playing a huge role. And so I like to think of hormones, and when I am talking to adults who are probably less well informed than you guys are, I always say that a hormone is the body's chemical messenger. And basically it moves throughout the body, communicating messages to different organs and tissues in many different ways. And of course, I'm sorry this picture didn't show up, but you'll have to trust that it was a picture of a brain, because a lot of hormones are produced by different organs in the brain, and they affect everything in the body. So this again probably is not news to any of you, but hormones can control our hunger, our thirst, adrenaline, fight or flight, a lot of things related to reproduction, menstrual cycle, pregnancy, breastfeeding, as well as mood. And there are, probably if you asked 10 different people what were the top 8 fertility hormones, you might get 10 different answers. But for me, this is how I define sort of the top 8 fertility hormones. And I believe a lot of these are familiar to you guys. Which ones are familiar?
We know about so many.
Okay, here's a better question. Which ones do you not know about?
AMA.
Oh my gosh, thank goodness, because that is all I'm going to talk about today. So really, this is where I'm going to spend most of my time. So all of these are really important in reproduction, but we're really not going to spend too much time there. Really, this presentation today is about AMH, or anti-Müllerian hormone, and what it is doing in the body. And so quickly, I just want to bring up the female reproductive tract one more time. I glossed over all of this. You guys are experts, you guys know. But I'm going to dive into the ovary, and we're going to look at what's going on inside the ovary, specifically back to this question of what's happening with all of the eggs that are in there, why is it changing, and the role that AMH is playing in the ovary. So again, this is kind of a stylized picture of a cross-section of the ovary. And let me just walk through a few key things. So in purple, light purple, lavender down here, this is meant to represent eggs. And eggs live within follicles, which is illustrated by this sort of red-orange structure outside of the eggs. Now, does anyone know what a follicle is?
Do you want us to draw this on the board?
They can draw it.
Oh, yeah.
They identified that under the microscope as well.
Please do. Please draw it on the board. Yeah.
Wait, right now?
Yeah.
Go for it.
Yeah.
Yeah.
Can I have someone come with me?
Partners.
Yeah, no.
We're on the right.
Come on up, yeah.
A couple different-
Go Jada.
Go Jada, like, learn about Jada.
I'm just adding
What
what
the
you
follicle,
do.
you're like,
Yeah.
she was
What?
first.
I don't know, I blanked.
So this is, yeah, this is very stylized and this is very, very simplified.
Yes,
Bobby.
Bobby.
That's our first. So we have all of these little things in here, and then we have all the stages, so there's. Yes. And then one more that is the biggest one.
Graphian.
Yeah. So we got this thing over here. There's that little thing.
Yeah.
And
Yeah,
what is this? Just.
that's just ovulating.
Yeah. And there's lots more cells in
Yeah, yeah. No, but that's great. So you guys know this. You guys know this, so this won't come to us as a surprise to you, but maybe there are some things that I can help you or teach you today. So primordial follicles. This is, most of your eggs and your ovaries are primordial follicles. We consider them at rest or dormant. They're not really doing anything. They're sort of in a state of sort of frozen, right? And every month, some proportion of those primordial follicles are recruited to start folliculogenesis or follicle growth. And so exactly as you illustrated, right, these follicles are going through this maturation, this growth process through primary follicles, preantral, antral follicles. These follicles are growing, things are happening to the egg itself to prepare it for eventual, if it is lucky, ovulation, right? And one of the things, let's see, what did I want to mention about this? One of the things that I think is really important is that this dormant or resting state of follicles is pulled from every month, but it takes about 3 months to go from beginning to the end. But only one follicle every month is going to get to a stage where it actually ovulates. And so this gets back to your question: what is happening to all of these eggs inside all of these follicles if many of them are getting recruited every month, but we're only ending up with one? So it's it's like an inverse triangle. We start with a ton and we funnel down until we only have one. And a lot of that is controlled by hormones, and it's a give and take of hormone activity that controls this process. And so this is where I want to bring up AMH and the role that AMH plays. So AMH, interestingly, is not produced by any of the primordial follicles. So that huge store of eggs and follicles that are resting, AMH is not produced by those cells. AMH is only produced in the primary and preantral follicles. So not the totally mature antral or pre-ovulatory follicles, but in these follicles that are in a state of maturation. And what's really fascinating about this is that it allows you to use AMH as a readout of how many cells are here. So let's imagine we have 1,000 follicles that have started to develop. Each one of those follicles is going to be producing AMH. So you can think that we have 100 AMH, right? This is a little bit simplistic, but we have 100 times the number of cells that are producing AMH. Now, if we only have one cell that is maturing, right? Only one cell that is producing AMH levels are going to be about 100 times lower. And so by measuring AMH, by knowing how much AMH is there, you're getting a measure of this pool of follicles that are growing, but not a measure of the primordial follicles. Any questions on that? Thoughts? Perfectly clear. Perfectly clear. Good. Usually I'm perfectly clear, but not always. Okay. So this brings up the idea of ovarian reserve testing. So does anyone know what the word ovarian reserve refers to?
Is it taking eggs and, no.
No, continue your thought.
Is it like reserving eggs for later use?
Oh, that is a very good idea,
No.
but that is not it. But I like that, yes.
Is it like how many eggs that you have are developing, and so you're testing like your AMH levels?
That was very, very close. So the comment up here was, is it the number of eggs or follicles that are developing, but which is very much related. Ovarian reserve is really referring to this primordial follicles. How many are left, right? How many until we get to 0? And so while that does include the ones that are developing, the ones that are developing are typically small compared to the number that are remaining. So ovarian reserve testing is, how can we find ways to estimate how many eggs are left? Now, I'll tell you the way we don't have to estimate, we can know exactly, precisely how many eggs are left. And that means you have to take the ovary out, you will slice it up into sections, stain it, put it under a microscope, count every single one that's in there, and that's how you know precisely. But for obvious,
Can you restore that ovary?
no, it's gone. Like once you do that, it is gone, right? And so that has obvious limitations, because nobody is going to give up an ovary in order to see how many eggs happen to be there at that one time, right? That is just not practical. It's never going to be done. So doctors and clinicians and people really want to understand, well, how can we estimate how many eggs are left? Because that helps us specifically understand, maybe specifically is a wrong word, it gives us a better idea of how long until menopause, or another way to think about that, the reproductive years that someone has. So if you know I only have 1,000 eggs left, that gives you more information than if you knew I had 100,000 eggs left or 500,000 eggs left. So there's really, ovarian reserve testing is, how do we get an estimate of how many eggs are left? Specifically so you can use that for sort of future fertility planning, and just have more information about what's going on. Okay, so that's what ovarian reserve testing is. And why is this important? It's important because fertility changes with age. And there's two really important things that I wanna mention here. And it comes down to egg quality and egg quantity. So we spent a lot of time in the beginning talking about egg quantity. So at puberty, about 400,000. At menopause, approximately 0. That's egg quantity. What is the number? And if, this is my picture of 2 ovaries from a 20-year-old and a 40-year-old, just to illustrate that at 20 years old, there are many more eggs, a larger ovarian reserve, than in a 40-year-old. But what's also on here, and is a little bit more subtle, is the slight difference in color that you see in the 40-year-old. And that is meant to illustrate egg quality. Now, in addition to the number of eggs going down with age, the quality of those eggs go down with age as well. Now, this quality is really often just a proxy for the genetic health of an egg. And so birth defect rates rise with age, Down syndrome risk rises with the age of the mother, miscarriage rates rise with age as well, and all of this comes down to egg quality. Before we go any further, I want to say we do not have a test today, not we being me or my company or any company, for egg quality. There isn't a really good biomarker or measurement of someone's egg quality except for their age. The only slight caveat to that are some exposures to toxins or pollutants. So if you smoke, for example, that can decrease egg quality, but we don't have really a way of measuring it specifically. We just know that smoking or exposure to, let's say smoke, fires for, every year for years and years and years, that exposure could have an effect on egg quality, similar to any other toxins or pollution. So egg quality is one key piece, but unfortunately is not one that we're really able to assess other than someone's age. But really it's this egg quantity or the egg number that we're interested in. And this is why, again, I feel like this is repeating sort of the same point, but it's very, very important, which is that, well, actually, let me break down this graph first, and then we'll dive in. So on this graph, I'm showing two different trend lines. In blue, NGF, or non-growing follicles. So I previously referred to them as primordial follicles. They're sometimes also called NGFs, or non-growing follicles, and that is this blue line, and it's showing that every month to start folliculogenesis, there is the recruitment, remember, of follicles from that primordial pool, and at birth until about puberty, age 13, 12, 15, oh, not again. The number of primordial follicles that are recruited every month is increasing, and it peaks at around 900, 850, and so that means every single month, about 800, 900, 1,000 eggs are recruited and start this growing process. And then peaking at about puberty until menopause, the number of eggs that are recruited goes down. And what's really interesting about this is starting at about age 25, in red, this is AMH levels. Okay, so AMH levels fluctuate a little bit, and we can get into this in a minute. They fluctuate until they reach their peak at about 22, 23, 25. After that point, AMH levels and the non-growing follicle recruitment are highly correlated, meaning that AMH is a good estimate of the number of eggs that are being recruited every month. Okay, I'm going to pause there. Who has questions about what I just said? Or has thoughts about the implications of what I just said? Yes?
So the level of AMH determines how many eggs you have?
It's actually the other way around. The number of eggs you have determines how much AMH you have. And that is because the follicles themselves are producing that AMH. And so that's why AMH has really risen as a marker and a measure for ovarian reserve, because it is really well correlated with the number of eggs that are developing. And so again, as the whole pool goes down, the number that are recruited every month goes down as well. And so that's why AMH has been really useful for ovarian reserve estimation and testing. Yes?
Your last slide, you said that smoking affects the egg quality. Does smoking, exposure to smoke affect
Egg
fertility?
quantity? Yes. So now I'm not going to be able to give you the exact precise estimate, but women who smoke throughout their reproductive life reach menopause sooner. I think on the order of 1 to 3 years sooner. So not only is it affecting the quality, it is also affecting the number.
I have a question.
Yes?
Is it smoking anything, or like nicotine or tobacco?
Yeah,
or-
really, really great question. So a lot of this data we have is from data sets that, you know, they stopped recruiting people a decade ago or 20 years ago. You know, these were women in their reproductive ages in the 80s, in the 90s, in the early thousands. And most of that was cigarette, tobacco, smoke. It's only in recent years that we have e-cigarettes. It's only in recent years that marijuana has become legal, and therefore the number of women that are smoking marijuana or edibles or whatever it is has gone up. And so we really don't know, and this is a huge area of active research. I think if you spoke to a doctor who is treating patients, they would say, we don't know the effects, and therefore we assume it will be bad, because, you know, the worst case is people are having children and there's some sort of effect that we don't know yet, so their sort of perspective is it's best to not. But it's a very, very active area of research, and something that I am personally very interested in. And if we have time, I can talk a little bit more about what I do, but I oversee a lot of the research on modern fertility, and that's a question that I'm very, very interested in trying to understand, so that we can provide women better information about how things like that may affect quality or quantity to the best that we can estimate. Yeah. Any other questions? Okay, so to summarize, at around early 20s is when AMH starts becoming a, you know, it's sort of parallel paths non-growing follicle recruitment. And so that is when it becomes a very good estimator of ovarian reserve. The other thing that's really exciting about AMH, I don't know if exciting is the right word, it's exciting to me, is that AMH is highly variable. Now, you may think that that is perhaps not great. Wouldn't it be great if everyone had the same AMH and we could just track, know your AMH and know where you were? But what's fascinating about it is that it reflects the very large diversity in ovarian reserve and in AMH production in women. And so this graph is a little bit complex, but on the bottom we're looking at age, so from age 20 to age 50. And on the y-axis we're looking at AMH, and this is a log transformation of AMH that doesn't really have units, so we'll just say that at the bottom is no AMH to increasing AMH as you move up the graph. And what it's showing is from the 5th to the 95th percentile of AMH by age. And so let's take age 30. The 50th percentile at age 30 is somewhere around 17, let's say. Now, why is this so interesting? What I think is so fascinating about this is, let's see, what's the best? We'll go at age 35. At age 35, you have some women who have an AMH in the bottom 5th percentile that is about 2.5. Also at age 35, you have some women who have an AMH is literally off this chart because we aren't even getting to the point where the 90th and the 95th percentile is intersecting age 30. Which means some women, as we talked about before, have very low AMH, and it is estimated very low ovarian reserve, and at age 35, may be close to menopause. And we have some women who are off the chart high up here, who may be much, much further from menopause. Yes?
You can get menopause at 35.
Yes.
So, okay.
I'm just like,